This meeting is being recorded.
Greeting, Mr. Dr. Foad. We are Jun Ler and Chun Yao Ting. We are presenting Lab 1 for COA. Share the screen. Okay. Here is the part B. So I will step by step debugging and open 5 windows. So we press F10. Okay. So here got 5 window which is watch, auto, memories, register, and disassembly. So next we need to reference the pair. So we can see that our first double word is this four double word, right? So is 10,000. So it will become 000010 and 00. Okay, so for the value 2 it become 000004 and 00. For the value 3 it becomes 0000 and 02 and 00. So for the final value we haven't got anything. Then for the so now we can see our register still got something like see. So now okay, first we'll start move value 1 to the EAX. So this one EAX will become we'll start with 10,000. Okay, so it become 10,000. The EAX became 10,000. Okay, so next we'll add the EAX with the 40,000. So you either become 50,000. And then next is subtract 20,000. So we become 30,000. And then we will store the result by giving the EAX to the final value. So EAX to the final value now is 0, right? So it will become 30,000. 30,000. Okay. So next we will call the dump regs. So we will display the output at the terminal. So display the register. So next we will show the disassembly code. And here is our bytecode. Yeah. So next, that's it. So that's all for part B. Next, I will give my partner to explain the part C.
Oh, okay. Thank you, Jun Ler. And I will present the screen for part C. Let me present my screen. All right. Can you see my screen?
Yes.
Okay, so here is the lab 1C, lab 1 part C. Okay, so this program actually adds and subtract 8 and 16-bit unsigned integers and stores them in the variables. And here's the data segment. And then here's the code segment. So, all right. I think we can start debugging. So I put a breakpoint here because I want to start from here. So let's start debugging. All right. So we got 4 windows here, and another window is for disassembly. So the register window basically show how the register actually change. And the watch one is the variable we wish to observe. And then the autos basically what is changed in the debugging. And then we wish to see the memory of the address as well, address of memory as well. And then this is a disassembly code. And let me check the offset of the variables first. Our first variable, okay. So you can see it's arranged in a little Indian order. So vowel W1 is a word, right? So it occupies four digit now. So it's a hexadecimal representation. And then there's a 1000. And then the second is 4000. And the third is 20000. And then the final vowel W is a word, right? But we haven't defined it, so it's initialized as 0000. And then for the vowel B1, it's in byte, so it occupies two digit. So it's a 10, and then vowel B1, and vowel V2, 40, vowel B3, 20, and final vowel B is a 00, because it's initialized at 0. Okay, so we can finally start debugging. And at the first line, right, we want to move the value W1 into AS. So we basically initialize with 1000 hash. So we wish to see this register being changed to 1000. So let's F10. So you can see the AS is changed to 1000 here. And then the EAS is changed to 1000. And this thing doesn't change because it's extended AS, right? So the AS only affects this 4 digit. Okay. So can debug the second line. Second line is basically add 4000 into AS, which is the value of vowel2. So we expect this to be 5000, and then we expect this to be 5000 also. So F10, 5000, and then 5000. Okay. So another one, the next line we want to subtract vowel W3 into AS. So it will become 3000. So F10. So you see it become 3000, and here also become 3000. So then we want to move the final vowel W into AS. Wait, what's this? So we wish to see this being changed to 3000. Okay, so F10, 3000. And you can see the address change also, 3000. Okay, and then we want to call down register. Okay, right now the output screen is empty, but once we call it, it will being displayed here, and you can see 3000 here. And then let's move to next line. Next line basically move vowel B1 into AH. So AH is basically this two digit, okay? So you press F10, you count 110, I think, 110. You can see the AH and this being changed. And then F10 again, I'm going to add AH with vowel B2, so it will become 50 actually. 50, you see 50, 50, okay? So F10 again, we're going to subtract vowel B3 to H. So we come 310 at 30 actually. So 30. And then we move the AH into final vowel B. So final vowel B will be 30. So you see 30. Okay. Then last but not least, we call down registers. So F10, you can see the down register is the same also. So basically, this is a two-way of adding and subtracting from 8-bit and 16-bit. So And then last but not least, let's see the disassembly code. And here is the disassembly code. So basically, it shows the line number and then the variables actually, and the operand also. So there's a bytecode from here to here. Okay, then last but not least, we exit F10. Okay, so that's all from for our debugging process, and thank you very much.
Thank you.